nature are visible regular forms found in natural world. The patterns can sometimes be modeled mathematically and they include symmetries, trees, spiral, meanders, waves, flumes, cracks, tessellation, and stripes. Early Greek philosophers studied pattern with Plato, Pythagoras, Empedocles, attempting to explain order in nature. The modern understanding of visible pattern developed gradually over time. Mathematics, physics, and chemistry can explain patterns in nature at different levels and scales. Patterns in living things are explained by biological processes of natural selection and sexual selection. Studies of pattern formation make use of computer models to simulate a wide range of patterns.
Symmetry is one of the patterns that can be seen in nature, a pervasive pattern in living things. People, animals, and plants is symmetrical. Symmetry is a nature's artwork that creates harmony and a beautiful proportion of balance, something that all human beings look for and seem to intuitively understand. Digging deeper to this topic, symmetry has been classified into 5 types. These are the mirror or the bilateral symmetry, followed by the threefold, fivefold, sixfold, and the rotational or the radial symmetry. The following are the examples of symmetry that can be found in nature. According to splashlearn.com, in mathematics, especially in geometry and its applications, an object is said to have symmetry if it can be divided into 2 identical halves. Britannica.com said that symmetry refers to correspondence of body parts in size, shape, and relative position on opposite sides of a dividing line or distributed around a central point or axis.
Fractals are infinitely self-similar iterated mathematical constructs having fractal dimension. Infinite iteration is not possible in nature, so all fractal patterns are only approximate. Example, the leaf of ferns and umbellifer are only self-similar to 2, 3, or 4 levels. A fern displaying its fractal features, the same shape is repeated in the branches, the fronds and the leaves, and even the veins inside each leaf.
Spiral. Spiral are shapes that wind in a gradually or tightening curve. It is a curved pattern that focuses on a center point and a series of circular shapes that revolve around it is considered one of the most common in nature.
Examples of spiral: shells, banana leaves and stem of the squash.
Everything in nature exists for a reason. Every creation leads us into a beautiful discovery, new or even repeating patterns. They can be very well explained by theories of mathematics and science. Mathematics is indeed a beautiful language. It subtly explains the mysteries of nature and the patterns of emerging everywhere. A wave is a flow or transfer of energy in the form of oscillations that move through water, making a visible chaos. Sea waves or tides, a sound we hear, a photon of light traveling, and even the movement of small plants blown by the wind are all examples of different waves. Types of waves. Mechanical waves propagate through a medium, air or water, making it oscillates as they pass by. Last types of waves is wind waves. Wind waves are sea surface waves that create the characteristic chaotic pattern of any large body of water. Through their statistical behavior can be predicted with wind wave models. As waves in water or wind pass over sand, they create patterns of ripples.
What is tessellation?
According to Lisa Steen and Mia Primas, tessellation is simply a tiling that has a repeated pattern of one or more shapes.
For a pattern to truly be a tessellation, the shapes can't overlap and can't have no spaces between them.
The pattern can be created by rotating, translating, and reflecting the shapes.
Here are some examples of tessellation. Pineapple skin, lastly, agave angustifolia.
According to Wikipedia, cracks are linear openings that form in materials to relieve stress. When an elastic material stretches or shrinks uniformly, it eventually reaches its breaking strength and then fails suddenly in all directions, creating cracks with 120-degree joints. So 3 cracks meet at the node. Conversely, when an inelastic material fails, straight cracks form to relieve the stress. Further stress in the same direction will then simply open the existing cracks. Stress at right angles can create new cracks at 90 degrees to the old ones. Thus, the pattern of cracks indicates whether the material is elastic or not. In a tough fibrous material like oak tree bark, cracks form to relieve stress as usual, but they do not grow long as their growth is interrupted by bundles of strong elastic fibers. Since each species of tree has its own structure at the levels of cells and molecules, each has its own pattern of splitting in its bark.
Spots and stripes. Spots is a small round or roundish mark differing in color or texture from the surface around it. An example of spots is, as you can see, these ladybugs, or more accurately lady beetles, are well known for their spots. Although not all species of ladybugs do in fact wear spots, spotted or not, conspicuous colors serve as a warning to predators that they are toxic to eat. Stripes are made by a series of bands or stripes, often of the same whale in color along the length. An example of stripes is, as you can see, the snake plant. The leaves after getting mature turn into attractive dark green blades with stripes, depending upon the type of plant.
So, that's the different patterns that we can find in our nature.
We hope that you can learn something valuable about the patterns in nature, and we are also hoping that through this video, you can identify the patterns that found in it.
Thank you,
and God bless!